This is the recording for section 1.2 where we start to learn some basic formulas for taking derivatives. So these are just some examples of how to use those rules. So you absolutely must read section 2.1 first, where they present the rules, and these are going to be examples using those rules. So let's calculate some derivatives. Let's take the derivative of x squared plus 2 to the x. Now, it's going to be very important, as you may have figured out, that it's not this class is not just about finding the right answer. It's about explaining why you're doing things and showing that you actually understand the steps you are taking. So as such, I will require you to tell me which differentiation rules you are using when you are using them. So if I'm going to take the derivative of x squared plus 2 to the x, the first thing I need to do is use the sum rule to split that up into the derivative of x squared plus the derivative of 2 to the x. Now I can work with each piece individually, and I take the derivative of x squared using the power rule, so that's 2 times x to the first, plus the derivative of 2 to the x, which uses the exponential rule, so I have natural log of 2 times 2 to the x. And if I just simplify a little, I have 2x plus natural log of 2 times 2 to the x. Next example. Let's take the derivative with respect to m of 3m to the fourth. First thing I need to do is bring that constant out in front of the differentiation. I can do that via the constant multiple rule. So I have 3 times the derivative with respect to m of m to the fourth. Now to take that derivative, I use the power rule again. So that's 4m cubed, and that 3 is coming along for the ride. I simplify, I get 12m cubed. This example, I'd like you to find f prime of x, where f of x is 3 times the square root of 2. In other words, differentiate with respect to x 3 square root of 2. And before you get crazy or freaked out by that square root, notice that there's no x here. 3 square root of 2 is just a number. It's an irrational number, but it's just a number, so the derivative of a number is 0. And that's the constant rule. Doesn't matter what number it is, the derivative of a constant is always 0. So here's a slightly trickier example. I want to take the derivative with respect to x of the square root of 2 divided by the 7th root of x. Now, there are some fancy rules that are still to come involving quotients, but we don't need anything fancy like that. We just have to do a little bit of simplification first, and then we can apply the basic rules we've gotten in section 2.1. So let's do a little algebra and then do some calculus. So the first thing I'm going to do is I'm going to write this as the derivative with respect to x of the square root of 2 times 1 over x to the 1/7 power. So rewriting that root and rewriting the fraction a little bit. Now I'm going to rewrite that second piece even a bit more. This is the derivative with respect to x of the square root of 2 times x to the negative 1/7. So dividing by x to a power is the same as multiplying by x to negative that power. Now I have done some algebra, now I'm ready to take some derivatives. So I bring that square root of 2 out in front of the derivative sign because of the constant multiple rule. And then I'm going to hit that x to the negative 1/7 with the power rule. So I have the square root of 2 coming along for the ride times negative 1/7 x to the negative 1/7 minus 1. That's how the power rule works even for negative fractional exponents. And I simplify, I get negative root 2 over 7 times x to the negative 8 over 7.